Good morning, students. Welcome to the statistics class. Today's topic is curve fitting, practicals number 2. In the previous class, we have seen the practicals on fitting of straight line and fitting of second degree parabola. Today we are going to see fitting of curves like exponential and power curves. Now this topic is for semester 3 students. And we will start. Curve fitting. Again, practicals. We'll see. Fit an exponential curve of type y is equals to ae power bx to the following data, and the data is x takes the value 1, 2, 3, 4, 5, 6 and y takes the value 1.8, 2.5, 3.6, 4.7, 6.6 and 9.1. This is the problem given to us today. Now we have to fit a curve of type y is equal to ae power bx. And that y is equals to ae power bx, we call it as exponential curve. Now, this exponential curve, how are we going to fit? Let us see. Now, if we have to start the problem, in the previous class, I have told that we should start with aim. Now, what is our aim? See your question properly and then we have to write our aim. So, the question is fit an exponential curve of type y is equals to ae power bx to the given data. Now, aim is to fit an exponential curve of type y is equals to ae power bx to the given data. Now this is your aim. After aim, what we have to write? We have to see the procedure. What is the procedure? Let us see. The procedure is now we have to fit the equation of this type. Y is equals to ae power bx. Take log on both sides. Now this is not a linear curve. We have to convert this non-linear curve into linear, and then only we can apply the principle of least squares. That principle of least square which was given by the Lagrange, we can apply only to the linear curves. So the given non-linear curve, we have to convert it into linear by taking log on both sides. Now after taking the log on both sides, what are we going to get? Log y is equals to log of a into e power bx. Now if we multiply, log y is equals to log a plus bx log e. Now, since log e to the base e is equals to 1, what we can write here? Here. Since log e base e is equals to 1, applying this, what are we going to get? Log y is equals to log a plus bx into 1. That is bx. Now putting log y is equals to u and log of a is equals to capital A, this equation, what will it become? U is equals to a plus bx. Now what is this? This is the equation of straight line in terms of u and x. So let us say this is equation 1. This is equation 1, we'll put, and this equation 2. Now equation 2 is straight line in terms of u and a. Therefore, by applying the Lagrange's least square principle of least square, this equation of straight line, which is in terms of u and a, has the normal equations, and the normal equations are given by what it will be? Summation over I ui is equal to na plus b summation xi, and summation xi ui over I equals to a summation xi plus b summation xi square. Now this equation 3 and equation 4 are normal equations. By solving these two normal equations, we are going to get the two constants capital A and small b. Then afterwards, we convert them into small a, small b and substitute them in the equation 1. Therefore, we get the required equation, estimated equation for the exponential curve of type y is equals to ae power bx we are going to get. Now this is the procedure you have to write. Take the equation which is given to you, and it is obvious that the given equation is not linear equation. It is a non-linear equation. So with the non-linear equation we cannot do anything. So what we have to do is, we have to try and convert the non-linear equation into linear equation. That linear equation, how are we going to do? We will take log on both sides, and then it will become log y is equals to log a plus bx log e. And we all know that log e to the base e is equals to 1. Therefore, the required equation is log y is equals to log a plus bx. Now we consider log y to be u and log a to be capital A, and then we substitute and we got an equation of a straight line u is equal to a plus bx, which is in terms of u and a. Now if we have an equation of straight line, we know that it is a linear equation, and by applying the principle of least squares, we get the normal equations. With the help of the normal equation, we solve these two simultaneous equations and we will find out the values for the constant capital A and small b. Now capital A is what? Log small a. So small a value will be anti-log of capital A. We convert that and we get the values of a and b, and those values if we substitute in the equation 1, that is the required equation for the given data. This is the procedure you have to write. The first step would be the aim. Aim is taken from the question itself, and our aim is to fit a exponential curve of type y is equal to ae power bx. For that, the procedure is we have written this, and now we are going to do the calculation part. Now what is that calculation part? Let us see. What is given? X and y are given. Let us take x and y and try to solve the problem and substitute in the normal equation. Find a and b, then we'll see where we land up. Calculation. X values are given. What are the x values given? 1, 2, 3, 4, 5, 6. Y values 1.8, 2.5, 3.6, 4.7, 6.6 and 9.1. Now what we have in the normal equation, what all we have? Summation x. Yes, we get the summation x, and summation x is given as 21. And then summation y, we don't have y, but instead what we have? Ui. But what we have taken y to be? Y is nothing but u is nothing but log y. So all of you all have scientific calculators. In the scientific calculator, if you press 1.8 and log button, you are going to get the value directly, and that value is 0.255. BSc statistics students have to use scientific calculators. Because the problems will be very long, and in the examinations the time stipulated for your problems is half an hour, and for that you have to use the calculators, scientific calculators. Ordinary calculator you may not cope up with the time, so you are allowed to use the scientific calculators. Everybody should have, and you should be practicing it. If you practice only, you will get the this will not 3.658, and then so we got summation ui and summation xi. In the second one we have to got x square and xi ui. So next one is ux. So what is that value? 0.255. So 1 into 2.255. 2 into 0.397. That would be 0.794. And here it is 1.668. We are multiplying u and x. 2.688, 4.095 and 5.754. So overall total would be 15.254. We got this value. We have summation xi. Now we require x square. What is x square? X is 1. 1 square is 1. 2 square is 4. 3 square is 9. This is 16. This is 25. And this is 36. And the total is 91. Here. So we have converted a nonlinear equation into linear equation, and that we got it as a straight line. To the straight line we know the normal equation. With what we require for the normal equation from data we have found out. Now our task is to substitute the values into the normal equation. So what are the values that have to be substituted? Summation ui, that is 3.658 is equal to n. N is 6. 6a plus summation xib. Xi is 21. 21b. This is equation number 2. And what is equation number 3? Summation xi ui. The value is 15.254 is equal to A summation is 21a plus B is what? 91b. This is equation number 3. Now these two normal simultaneous equations with two unknowns, if we solve it, and how do we solve two unknown equations? Two equations with two unknowns and get the values. Let us see. Multiply equation 2 with equation 2 with 21 and equation 3 with 6. So what are we going to get? I am multiplying equation 2 with 21 and equation 3 with 6. So I am making these two terms equal, and then I do the subtraction so that A will be cancelled and there will be B, and we get the value of B. After getting the B value, we will substitute that B value in one of the equations and try to solve the equation and get the value of A. This is as simple as that. You have to make one of the constants multiply its now here we are trying to cancel A, so that the first equation we will multiply with 21 and the second equation with the 6, so that this term will be equal, and if we subtract each other then it's going to be cancelled and we are left with only one term B, and solving with the given value we get the value of B. Now so the terms will be 76.818 is equals to the 126A plus 441B, and here it is 91.524 126A plus 546B. If we subtract, we are left with minus 14.706 is equal to minus 105 B. Minus minus will get cancelled. Therefore, B is equal to 14.706 divided by 105. That implies B value is equal to 0.14. So we got the B value. From B value, we are going to extract the A value. How are we going to do that? Substitute B is equal to 0.14 in equation 2. We get, now see, what is equation 2? 3.658 is equal to 6A plus 21B. Now, that implies 3.658 is equals to 6A plus 21B is what? 0.14. That implies 6A is equals to 3 minus 58 minus 2.94. This implies 6A is equals to 0.718 divided by 6. Therefore, A value is equals to 0.119. But we don't require capital A. We have taken small a to be antilog of capital A. That value is equals to 1.315. Therefore, inference will be the required equation is y cap is equal to A e power b 0.414 x. This is the required equation. Now you have to solve the problem in this form and in this order. I am going to give you 2 more equations and 2 more data sets which you try and solve according to your understanding. If you stuck somewhere, please do contact me. I'll try to resolve your doubts. Okay? Now I am going to give 2 more equation of different forms. One is exponential and one is power curve. Follow the same steps and you try to do it, but I'll give you the procedures for both of them. Let us see. fit an equation, fit an exponential curve of type y is equal to AB power x to the given data. And the data is x, y, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and y values 3.16, 2.38, 1.75, 1.34, 1 and 0.74. Now the solution. A. So what is our aim? To fit an exponential curve of type y equals to AB power x. Now what is the procedure? Y is equal to AB power x. Take log on both sides. Why? Because the given equation is not a linear equation. Log on both sides. To convert it into linear equation, we take log on both sides. Now, log y is equal to log of AB power x. Now that will be log y equals to log A plus x log B. Now put log y equals to u, log A is equals to capital A, and log B is equals to capital B. So the equation has reduced to u is equals to a power a plus xb. Now this is the linear equation in terms of u and capital B, u and x. So the linear equation will have normal equations. Normal equations are ui equals to na plus b summation xi and then summation xi ui equals to a summation xi plus b summation xi square. Now this is the linear equation. We have converted non-linear equation into linear equation. Then we have written normal equations for this linear straight line, and then with the help of this we are going to do the calculation and solve. You are continuing with the problem from here. Calculation part and inference part you are going to finish it off. Now we have been given x's, then y, x and y are given. What all we require? ui. What is ui? Log y. And then what else we have taken? Log a is equals to log b. Now here in this summation ui is there, summation xi is there. Now summation x square and then ui into x. Now you solve this, do the calculation part here and get the summation and substitute into these two normal equations and solve those two simultaneous equations with two unknowns. You get the unknowns and you get the capital A, capital B values. But our capital A is log A. We require small a. So what do we do? Capital A, small a is equals to antilog of capital A and small b is equals to antilog of small b, and then substitute that value and write the inference. Hope you will do this as a homework, and half the way I have finished. The remaining half, only the calculation parts which I have given what table you should have. You put on the table and from the table you substitute the values in the normal equations, solve them and write the inference. Hope you do it. If you are stuck somewhere, please do contact and clarify your doubts. Now this is it for today's class. Thank you.